Hi friends, welcome to GMK tutorials. ఇప్పటివరకు ఎవరైనా ఛానల్ సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే సో ప్లీజ్ సబ్స్క్రైబ్ అవర్ ఛానల్. Okay, so in this video we are going to discussing about the state machine concept. In the previous video we will discuss the USB protocol analyzer or design overview. Now we will go into, suppose if you have some idea about the design overview, then you have to design a mission. Okay, how you are going to design that mission and what are the responsibilities of that mission, that is very important. So for that purpose, let us see what is our considerations here. So in order to able to decode the incoming USB data from the proper packet types, check the packet ID and the data transmission errors and output packet type and the transmission status information to the outside world, it is necessary to design a state machine. Suppose if you want to design a state machine, the responsibilities of the state machine is, first of all, you have to identify the proper packet type. What kind of the packet type is, what type of the packet is going to be received. Then what is the packet ID? Okay, what is the data? In case if the packet ID is properly reached, then you have to check for the packet ID errors. If there are no packet errors are present, then you can decide what kind of the packet it is, a token type or data packet, or is there any special packet. So after completion of that one, you have to check for the data. If the data packet is received, then again you have to check the, is there any errors present in the data transmission. So that kind of the analysis also going to be carried out by the state machine also. So that the complete information is given to the outside world, it is necessary to design a state machine. Second thing is nothing but a state machine essentially consisting of a set of states and transitions between those states governed by the values of a several bits. Suppose if the state machine means that it consisting of a number of states, that state transitions are going to be carried out from one state to the next state, that information can be represented in the form of a digital bits. That is nothing but we can represent the several status bits. That's status bits indicates the how the transitions are takes place within the states. Okay, so the state should encode the current interpretation of the past USB packets observed thus far, and state transition should occur whenever the receipt of a new bit changes in the current interpretation. So in the state machine itself also you have to maintain the previous information. If the new bit is added to the current state, what is the next effect? Is there any changes in the states, or it may be same effect will be present in the same state. So that kind of knowledge is also necessary for the state machine. As well as initially we should expecting this synchronization field that denotes the beginning of the all types of packets. So in the state machine, first of all, if you want to transfer the data between any two devices, first of all you have to synchronize those devices. So for that purpose, first of all we have to expecting the synchronous field. The synchronous field is responsible for synchronizing those two devices, that means sender and receiver. After that, once the synchronization field is received correctly, okay fine, then what should we do? We should expecting for the packet ID field. Okay, so this packet ID field gives the information regarding the what kind of the packet is sent by the sender, that is recognized with the help of a packet ID field. Okay, even though if the packet ID is exactly reaching, if the packet are not, that can be recognized by the packet ID subfield. That means packet ID checker, that is also consisting of, it is a packet ID is consisting of 8 number of bits. So in this 8 bits of data, okay, in this 8 bits of data, first 4 bits are used for 8 bits of data is there. Okay, so it consisting of a 8 bits of data. So in this 4 bits are for 4 bits for packet ID. Okay, packet ID, and the remaining 4 bits are used for check bits. Okay, these check bits are used to decides the packet ID information exactly reached to the receiver or not. So that is the most important bits. These check bits also we can call as a redundancy bits, right? So second thing is nothing but if the packet ID information is exactly reached, no errors are present, then what shall we do? We should expect the data. Okay, if the data is exactly reaching or not, that can be decided by the, again we have some CRC bits is there. Okay, CRC bits are used. Check redundancy, okay, cyclic redundancy check. So these bits are 5 bits CRC and 16 bits CRC. So these two CRC bits are used for the recognizing is there any errors are present in the corresponding data. So it is at the same time the corresponding data packet is followed by the EOP. EOP is nothing but end of the packet indicator. Okay, if the data is suppose if the packet is a handshake packet. Handshake packet means if the information is received to the receiver exactly, the receiver gives you some acknowledgement to the sender. Okay, I got the data. So that kind of the packet is generally called as a handshake packet. At that time we don't expecting any kind of the EOP, we don't want to require any of the, so immediately it follows the again packet ID information. Okay, at the same time finally if the packet is finally if the packet is preamble packet, then ideal ideal field followed by the low speed packet is also to be expected. So that means here, okay, an ideal, so sorry, ideal field followed by the low speed packet is to be expected. That means preamble packet means this is sent by the host, okay, USB host controller. So the preamble packet means whenever the preamble packet is sent by the host means that all the low speed devices or high speed devices, you have to operate it in the low speed mode only. So for that purpose this preamble packet is used. Because of our intention is we have to design a full speed mode, if even though if the preamble packet is sent by the host controller, so we can ignore it because of we are operating in the full speed mode only. Okay, so it is only used for the design for full speed mode, so we will support it, then the preamble packet is to be ignored. Okay, so that is nothing but state mission. Okay, so let us see in our Telugu also. So state mission అంటే ఏం లేదండి, సపోజ్ ఇఫ్ యు ఆర్ గోయింగ్ టు డిజైనింగ్ ఎనీ ఒక మిషన్ ఒక సిస్టమ్ డిజైన్ చేయాలంటే ఫస్ట్ ఓవర్ వ్యూ ఉండాలని ప్రీవియస్ వీడియోలో చూసాం. ఓవర్ వ్యూ వచ్చిన తర్వాత ఏం చేయాలి, మిషన్ ఎలా డిజైన్ చేయాలి, మిషన్ డిజైన్ చేసి మిషన్ యొక్క రెస్పాన్సిబిలిటీస్ ఏంటి, ఎలా పర్ఫామ్ చేయాలి. సో దీస్ కైండ్ ఆఫ్ ది సినారియోస్ ఆర్ వెరీ ఇంపార్టెంట్. సో ఈ వేస్ లో చూసామంటే, సో ఈ స్టేట్ మిషన్ ఏం చేయాలంటే ఫస్ట్ ఆఫ్ ఆల్ యూ హ్యావ్ టు ఐడెంటిఫై ది ప్యాకెట్ ఐడి టైప్ ఏంటి, what kind of the packet is received by the corresponding receiver. So that information get from the packet ID field. So the packet ID field లో మనకి two fields ఉంటాయి. ఒకటి packet ID information, second one packet ID checker. So packet ID checker లో ఉన్న 4 bits యూస్ చేసుకొని packet ID కరెక్ట్ గా వచ్చిందా లేదా చెక్ చేసుకుందాం. ఆ packet ID కరెక్ట్ గా ఉంది అంటే then you have a capability to decide what type of the packet is going to be transmitted by the transmitter information also. So that is given to the outside world ఇవ్వాలి. సో ఈ స్టేట్ మిషన్ ఏం చేస్తాం, ఒక స్టేట్ నుంచి స్టేట్ మిషన్ మీన్స్ ఇట్ కన్సిస్టింగ్ ఆఫ్ ఆబ్వియస్లీ ఏ సెట్ ఆఫ్ స్టేట్స్ ఉంటాయి. ఓకే, ఈ సెట్ ఆఫ్ స్టేట్స్ లో ఉంటే సో దట్ స్టేట్ ట్రాన్సిషన్స్ ఒక స్టేట్ నుంచి ఇంకొక స్టేట్ కి ట్రాన్సిషన్ జరిగినా కానీ దట్ ఇన్ఫర్మేషన్ కెన్ బి గివెన్ బై ది ఎక్స్టర్నల్ వరల్డ్ బై యూజింగ్ ఏ సెవరల్ బిట్స్, స్టేటస్ బిట్స్ యూస్ చేసుకుని ట్రాన్సిషన్ జరిగాయని మెన్షన్ చేస్తాం. ఎట్ ది సేమ్ టైం ఈ స్టేట్ మిషన్ ఏం చేయాలి, ప్రీవియస్ నాలెడ్జ్ అంటే ప్రీవియస్ కరెంట్ ఇన్ఫర్మేషన్ నుంచి మెయింటైన్ చేయాలి. ఇన్ కేస్ నెక్స్ట్ బిట్ ఏదైనా ఇన్పుట్ యాడ్ అయితే సో వాట్ ఇస్ ద స్టేట్ ట్రాన్సిషన్, నెక్స్ట్ స్టేట్ గా ట్రాన్సిషన్ జరుగుతుందా లేదా అని ఐడెంటిఫై చేసేటట్టు ఉండాలి. సో ఈ స్టేట్ మిషన్ డిజైనింగ్ ప్రాసెస్ లో స్టేట్ మిషన్ ఫస్ట్ ఏం చేయాలి, ఫస్ట్ ఆఫ్ ఆల్ ఇట్ షుడ్ బి ఎక్స్పెక్టింగ్ సింక్రనైజేషన్ ఫీల్డ్ ఎక్స్పెక్ట్ చేస్తుంది. సింక్రనైజేషన్ ఫీల్డ్ ప్రాపర్ గా రిసీవ్ అయిందంటే then it will expect the packet ID field. If the packet ID field is exactly reached, it will expecting for the data field. If the data packet is correctly received with the by checking by if the packet is checked with the help of the CRC bit, if the CRC bits are correct, then data is also correct. If the data packet end low, we can expecting end of the packet. Okay, and the correct complete అయిపోయిందని. Suppose if the packet అనేది data packet కాదు, handshake packet అంటే receiver sender కి పంపిస్తున్నారు, I got the data some information regarding. So at that time we don't want expecting the end of the packet expect చేయాల్సిన అవసరం లేదు. If suppose the packet అనేది preamble packet అయితే, okay, so that means all the devices are going to be operated in the low speed packet is going to be activated. అంటే మనకి పంపించే డేటా అనేది లో స్పీడ్ లో వస్తున్నప్పుడు మాత్రమే ఈ ప్రియంబుల్ ప్యాకెట్ ని పంపిస్తాం. సపోజ్ హవెవర్ ఫర్ దిస్ డిజైన్ ఓన్లీ ఫర్ ఫుల్ స్పీడ్ మోడ్ లో డిస్కస్ చేస్తున్నాం కాబట్టి వీ కెన్ ఇగ్నోర్ ది ప్రియంబుల్ ప్యాకెట్ ని ఇగ్నోర్ చేస్తాం. సో దట్ ఈస్ నథింగ్ బట్ స్టేట్ మిషన్. I hope this video is very clear for you. Okay, so thank you for supporting GMK tutorials guys.